Leviton media panels are designed for low-voltage applications such as housing structured cabling, networking equipment, and audiovisual components. They are not under ITER's laboratories listed for use with line voltage applications. Using a media panel to house 110-volt circuit boards poses significant electrical safety risks. Line voltage wiring requires a proper enclosure certified for electrical safety. Media panels do not meet these requirements and could expose users to electrical shock. Short circuits or loose connections in the media panel could ignite a fire, especially if the enclosure is not properly ventilated. Instead of using a media panel, consider one of the following alternative mounting options for your 110-volt circuit boards. Firstly, use a metal electrical enclosure designed for line voltage applications. These enclosures provide proper ventilation, grounding, and electrical safety. Secondly, a recessed wall box can be installed behind drywall and provides a concealed space for mounting the circuit boards. Ensure that the box is appropriately sized and has adequate ventilation. Thirdly, commission a custom enclosure that meets your specific requirements, including size, ventilation, and mounting options. Using a Leviton media panel for line voltage applications is not recommended or safe. Opt for alternative mounting options that comply with electrical safety standards and provide adequate protection for your circuit boards and users. When working with electrical systems, it's critical to prioritize safety and adhere to established codes and standards. The National Electrical Code, or NEC, sets the benchmark for safe electrical installation. It's essential to consult the latest edition of the NEC and local regulations to ensure your project complies with all applicable rules. A key concern when dealing with electrical components is proper enclosure. Enclosures protect against accidental contact with live parts, preventing electrical shock. They also help contain potential fires caused by short circuits or equipment failures. The type of enclosure required depends on the voltage level and environmental conditions. For line voltage applications, such as the 110-volt circuits in this project, enclosures must be specifically listed for that purpose. Media panels typically used for low-voltage data and communication wiring do not meet these requirements. Instead, metal electrical enclosures are the standard choice. These enclosures are designed to withstand the stresses of line voltage and provide a robust barrier against electrical hazards. They also incorporate grounding provisions, which are essential for safety. Grounding provides a low-impedance path for fault current, helping to quickly trip a circuit breaker or fuse and energize the circuit. This prevents dangerous voltage from appearing on the enclosure itself. In addition to electrical shock protection, enclosures also play a vital role in fire safety. Electrical faults can generate significant heat, potentially igniting nearby materials. Metal enclosures are inherently fire-resistant and can contain a fire within the enclosure, preventing it from spreading. Proper ventilation is another critical consideration. Electrical components generate heat during operation. If this heat is not dissipated, it can lead to overheating and premature failure. Enclosures should be sized to provide adequate space for the components they house and should have ventilation openings to allow for air circulation. The size of the enclosure is determined by the number and size of the components it needs to accommodate. It's important to allow sufficient space for wiring and connections. Overcrowding an enclosure can make it difficult to work on the system and can also restrict airflow. When selecting an enclosure, consider the environmental conditions in which it will be used. If the enclosure will be exposed to moisture, dust, or corrosive substances, it should be rated for those conditions. NEMA, or National Electrical Manufacturers Association, ratings provide a standardized way to specify the environmental protection offered by an enclosure. For example, a NEMA 4 enclosure is designed to be watertight and dust-tight, making it suitable for outdoor use. In addition to using proper enclosures, it's also important to follow safe wiring practices. All wiring should be done in accordance with the NEC and local regulations. Use the correct wire size for the circuit amperage and ensure that all connections are made securely. Avoid overloading circuits, which can cause overheating and potential fire hazards. Before working on any electrical circuit, always de-energize it by turning off the circuit breaker or removing the fuse. Use a voltage tester to verify that the circuit is de-energized before proceeding. Wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. When working in confined spaces, ensure that there is adequate ventilation. Avoid working alone, so that someone can assist you in case of an emergency. If you are not comfortable working with electricity, hire a qualified electrician to do the job. The electricity can be dangerous, and it's always better to err on the side of safety. In the specific case of automating outdoor roll shutters, several additional factors need to be considered. Firstly, the control system should be designed to be reliable and fail-safe. The shutters should not be able to operate in a way that could cause damage or injury. Secondly, the control system should be protected from the elements. Outdoor locations can be harsh, with extremes of temperature, humidity, and sunlight. The control system should be housed in a weatherproof enclosure, and all wiring should be protected from moisture. Thirdly, the control system should be accessible for maintenance and repairs. The enclosure should be located in a place where it can be easily reached. It's also a good idea to keep a wiring diagram and other documentation inside the enclosure. When choosing a keypad or other control devices, select models that are designed for outdoor use. These devices are typically more rugged and resistant to the elements. Ensure that the keypad is mounted securely and protected from vandalism. Finally, consider the power source for the control system. If possible, use a dedicated circuit to power the control system. This will prevent the control system from being affected by other loads on the circuit. It's also a good idea to install a surge protector to protect the control system from voltage spikes. In summary, when working with line voltage electrical systems, safety should always be the top priority. Use proper enclosures, follow safe wiring practices, and consult the NEC and local regulations. For outdoor applications, take extra precautions to protect the system from the elements. By following these guidelines, you can ensure a safe and reliable installation. Now, let's delve deeper into the specifics of choosing the right electrical enclosure for your 110-volt circuit boards designed to automate the outdoor roll shutters. Selecting an appropriate enclosure involves several key considerations, including material, size, NEMA rating, and grounding. Firstly, the material of the enclosure plays a crucial role in its ability to withstand environmental factors and provide adequate protection. Metal enclosures, typically made of steel or aluminum, are the most common choice for line voltage applications. Steel enclosures offer superior strength and durability, making them suitable for harsh environments where physical impact is a concern. Aluminum enclosures, on the other hand, are lighter in weight and offer excellent corrosion resistance, making them ideal for outdoor applications where exposure to moisture is likely. Plastic enclosures are also available, but they are generally not recommended for line voltage applications due to their limited ability to dissipate heat and provide electrical shielding. Secondly, the size of the enclosure must be sufficient to accommodate all the circuit boards and associated wiring while providing adequate space for ventilation. Overcrowding an enclosure can lead to overheating and make it difficult to perform maintenance or repairs. A good rule of thumb is to allow at least 25% extra space within the enclosure for future expansion or modifications. To determine the appropriate size, measure the dimensions of all the components that will be housed inside the enclosure, including the circuit boards, power supplies, terminal blocks, and wiring. Adapt the dimensions and then add 25% to account for extra space. Ensure that the enclosure you select is large enough to accommodate all the components comfortably. Thirdly, the NEMA rating of the enclosure indicates its ability to protect against environmental hazards such as moisture, dust, and corrosion. NEMA ratings are standardized by the National Electrical Manufacturers Association and provide a clear way to compare the protective capabilities of different enclosures. For outdoor applications, a NEMA 3R or NEMA 4 enclosure is typically recommended. A NEMA 3R enclosure provides protection against rain, sleet, and snow, while a NEMA 4 enclosure offers more comprehensive protection against water, dust, and hose-directed water. In areas where the enclosure will be exposed to corrosive substances such as salt spray, an M4X enclosure made of stainless steel or fiberglass is recommended. Fourthly, proper grounding is essential for electrical safety. The enclosure must be grounded to provide a low impedance path for fault current, helping to quickly trip a circuit breaker or fuse and to energize the circuit in the event of a fault. Metal enclosures typically have a grounding lug or stud that can be used to connect a grounding conductor. The grounding conductor should be sized according to the NEC and connected to a grounding electrode system. In addition to the above considerations, there are several other factors to keep in mind when selecting an electrical enclosure. These include the type of enclosure, the mounting method, and the accessories. There are several types of electrical enclosures available, including surface mount enclosures, flush mount enclosures, and freestanding enclosures. Surface mount enclosures are mounted directly to a wall or other surface. Flush mount enclosures are recessed into a wall or other surface. Freestanding enclosures are typically used for larger equipment and are mounted on a floor or pad. The mounting method depends on the type of enclosure and the location where it will be installed. Surface mount enclosures are typically mounted using screws or bolts. Flush mount enclosures are mounted using brackets or clips. Freestanding enclosures are typically mounted using anchor bolts. A variety of accessories are available for electrical enclosures, including knockouts, vents, filters, and locks. Knockouts are pre-punched holes in the enclosure that can be used to run wiring. Vents allow for air circulation to prevent overheating. Filters prevent dust and other contaminants from entering the enclosure. Locks prevent unauthorized access to the enclosure. In the specific case of automating outdoor roll shutters, you may also want to consider an enclosure with a clear cover. This will allow you to visually inspect the circuit boards without having to open the enclosure. It is also important to select an enclosure that is aesthetically pleasing and blends in with the surrounding environment. You may want to consider an enclosure that is painted to match the color of the building. Remember to consult with a qualified electrician to ensure that you are selecting the correct electrical enclosure for your application and that it is installed in accordance with all applicable codes and regulations. Choosing the right enclosure is a critical step in ensuring the safety and reliability of your electrical system. Beyond the enclosure itself, the wiring methods used to connect the 110-volt circuit boards are equally important. Proper wiring techniques not only ensure reliable operation, but also minimize the risk of electrical hazards. Let's explore some essential wiring considerations. Firstly, wire selection is paramount. The wires you choose must be appropriately sized for the amperage they will carry. The National Electrical Code, specifically Table 310.15b16, provides ampacity ratings for various wire sizes based on their insulation type and ambient temperature. It's crucial to consult this table to ensure that the wires you select can safely handle the expected current. Using undersized wires can lead to overheating, insulation damage, and even fire. Secondly, insulation type is another critical factor. Wires are available with different types of insulation, each suited for specific environmental conditions. For indoor applications, thermoplastic high heat resistant nylon coated, or THHN, insulation is commonly used. For outdoor applications or areas exposed to moisture, wet location rated, or XW, insulation is recommended. XW insulation is designed to withstand moisture and prevent corrosion. Thirdly, conduit is essential for protecting wires and providing a secure pathway. Conduit is a tube or channel through which wires are run. It provides mechanical protection, shielding against physical damage and environmental factors. Several types of conduit are available, including rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and flexible metal conduit, or FMC. RMC and INC offer the highest level of protection and are suitable for both indoor and outdoor applications. EMT is lighter and easier to bend than RMC or IMC, making it a good choice for indoor applications where mechanical protection is less of a concern. FMC provides flexibility and is often used for connecting equipment that may need to be moved or adjusted. Fourthly, wiring connections must be made properly. Loose or corroded connections can create resistance, leading to overheating and potential fire hazards. Use appropriate connectors for the wire size and type. Ensure that connections are tight and secure. Consider using antioxidant compound on aluminum conductors to prevent corrosion. Fifthly, grounding is crucial for safety. All metal enclosures and equipment must be properly grounded to provide a low impedance path for fault current. Use a grounding conductor of the appropriate size and connect it to a grounding electrode system. Sixthly, labeling is essential for identification. Label all wires and circuits clearly to facilitate troubleshooting and maintenance. Use wire markers or labeling machines to create durable and legible labels. Seventhly, strain relief is necessary to prevent stress on connections. Use strain relief connectors or clamps to secure wires at entry and exit points. This prevents the wires from being pulled or damaged. Eighthly, neatness is important for organization and safety. Run wires neatly and organize them using cable ties or clamps. Avoid creating tangled messes of wires, which can make troubleshooting difficult and increase the risk of damage. Ninthly, overcurrent protection is critical. Each circuit must be protected by a circuit breaker or fuse of the appropriate size. Overcurrent protection devices prevent excessive current from flowing in the circuit, which can cause overheating and fire. Tenthly, compliance with codes and standards is mandatory. All wiring must be done in accordance with the National Electrical Code and local regulations. Consult with a qualified electrician to ensure that your wiring is compliant and safe. By following these wiring best practices, you can ensure a safe and reliable electrical system for your automated outdoor roll shutters. Remember that electricity can be dangerous, and it's always better to err on the side of safety. If you are not comfortable working with electricity, hire a qualified electrician to do the job.